Okay, ladies and gentlemen, a very warm welcome here on the last day of the ANGA-Com in Cologne. Also from my side on the third day, a very warm welcome for you, and I have the pleasure to chair this panel session today. I think it's the first one in the morning, and may I introduce myself firstly, that I am Dominik Röske. I work here in Germany for the Federal Ministry for Economic Affairs and Climate Action, and we are responsible for any kind of radio regulation and especially also radio equipment regulation. And we see that technology evolves faster and faster, and so the development of new generations of wireless access techniques is accelerated more and more. And that means we are in a strong need for especially a smart and very fast standardization to support this evolvement. And the unit where I work for is also responsible for ICT standardization. And for us, it's quite important to make these new techniques as fast as possible also available for the market and for the customers to use them and to profit from the benefits they enable. So today we will talk about the further evolvement of 5G up to Wi-Fi 7 and what is in between. And this title gives us already a hint that the upcoming technologies of wireless access may merge also together more and more. That means that perhaps some radio access technologies are perhaps not longer exclusively used by different kind of applications or devices. For example, perhaps also broadcasting will merge to 6G. And these standards may move to the home broadband as well. So everything will perhaps be mixed up in the future. And therefore, there's a strong need for more and more bandwidth, of course, because we have more and more devices and items that are connected to or over the internet. So, but this evolvement of these new technologies I mentioned before need a regulatory environment. Ideally, a worldwide one, of course, but at least one, from our point of view, a European one. And we are in favor to have a harmonized approach with clear rules that have to be fulfilled by the manufacturer to place radio equipment on the market. As I said before, we are also responsible for the regulation of radio equipment, and our aim is to have safe and secure products, but without too much burden for the manufacturers to place them on the market. It's our aim that everyone can access the market to the same transparent and fair conditions without especially mandatory certification requirements and so on. And therefore, standardization is the key, and the application of these standards is the way forward so that the new technologies are accepted by the broad majority of the user to use them, and of course by the manufacturer to produce them. But part of this regulatory environment is also the establishment of requirements to be fulfilled by the manufacturer, and in the aspects of especially IT security, we have new mandatory requirements to be fulfilled by August 2024. So that means that everyone who wants to or who will place products on the market after the 1st of August 2024, new requirements have to be fulfilled. And I would like to give you a small introduction, very, very shortly, to these new European requirements, because it's a European regulation, and it's the status on the current EU regulation on cybersecurity of products that have to be fulfilled, as I said before, by August. So very shortly, I would not like to read the text, but this is a delegated regulation. That means that the Commission has used an empowerment to set up additional rules to be fulfilled by the manufacturer, especially for internet-connected radio equipment. And there are two possibilities for the manufacturers to comply with these rules. The first one is to carry out a self-assessment and use harmonized standards. And the second one is to involve a notified body in the conformity assessment procedure. But to be able to use the first possibility, it's necessary that a standard is available, and therefore the request for this standardization mandate is, or the draft of the standardization request is was already developed by the European Commission and will be issued shortly. And then we hope that the standardization, the standard itself, will be available in time so that the manufacturer have the possibility to use them just in time because the products that will be placed on the market after the 1st of August have to comply with these new requirements. This very shortly, and I would like to welcome now Darrell Galasso from Amphenol Broadband Solutions, an excellent speaker today, this morning. Very warm welcome from my side for the next presentation, 5G plus next generation networks, a more connected world. The floor is yours, Darrell.
Thank you. Good morning, everyone. As you mentioned, my name is Darrell Galasso, and I'm the general manager of Amphenol Broadband Solutions based in the United States. Been in the broadband industry for about 15 years now, the first section of my career in the finance side of things, so I don't want that being held against me. I actually think outside of the box now, so I've tried to correct the error in my ways. What I'd really like to spend some time doing is talking about 5G and next generation networks. So that means a lot of things to a lot of people, and as this evolves, I think it's going to continue to change, and what we think about 5G will continue to change. So what I thought would be good today is maybe talk a little bit about what we're seeing and what we think will continue to be the evolution. With 5G, connectivity will continue to expand, and in the decade ahead, much of the blank space coverage will be lit up, and you'll see just a multitude of devices coming online, many out of the non-traditional sector that we're not used to. And it's going to change the way we look at things. It's going to change the way I think the world works, and hopefully for the good. So what it means is a more connected world. As you can see here, right now, if you think about it, we use devices for people-to-people interaction through social media, through texting, through email. I know if you have kids my age, it's become their lifeline. I'm not sure they actually know how to physically communicate to people anymore. Everything is over a device. But as you can see, the world's going to start evolving towards people to machines, people to vehicles, vehicles to vehicles, and just an integrated business world that will continue to leverage off of information and technology. What we see here is that 5G is really going to work in tandem with the fiber and HFC networks to provide a ubiquitous high-speed network over broadband. The fiber will really allow us to provide a direct broadband connection, and perhaps more importantly, the high speed and the low latency of the fiber will allow us to be able to move into these kind of case studies that we're going to talk about in a few minutes and be able to enable this expansion of coverage. So I think one of the key points here is 5G is not simply defined as a next generation wireless network. Right now, all the marketing is from the wireless carriers, right? From the Verizons, the Orange, the T-Mobiles of the world, talking about the improved cell coverage you're going to get. But what we really want to think about today is to consider it the next generation of advanced and frontier connectivity. In the next decade, the multitude of things connected to these new networks are going to expand by magnitudes, not just the normal progression we've seen. So if you think about the advanced networks, you're going to have the low to mid-band 5G, where we'll get high speed, low latency over, expanded 4G networks. But on top of that, we're really going to get into the high band 5G. And quite frankly, that's going to give us an additional high speed, but really the low latency and the high secure connections that we need for these next generation automation, manufacturing, mobility to really be able to drive forwards. So what I thought would be good is to talk a little bit about manufacturing first, because we've always thought about 5G really in the outside world, right? People to people and starting to get into more of the mobility. But manufacturing is an area where I think you're going to see some massive growth, and it's going to allow for businesses to really expand their reach to everyone. Almost half of all the 5G Internet of Things cases will be linked to these applications. You know, we talk about the Industry 4.0, you know, autonomous systems in factories. I had the chance to visit the BMW factory a few years ago, and this was a factory that went from 5,000 auto workers assembling vehicles to about 1,000 robots and 500 people. And they told me that's only the first phase of what's a continued expansion. So what's going to be needed, though, is continued data, continued ability to expand the communication between these machines. If you look at the smart cities and HD cameras for public safety, the ability for remote monitoring of these types of applications will continue to need bandwidth. You look at smart energy with the smart grids that are going on. You look at connected offices with video surveillance, with sensor-based building maintenance with regards to air conditioning, with regards to air quality that's become so important now post-pandemic, and the ability to ensure you have proper circulation. You talk about smart security with border security, with emergency medical services. Just the ability to have these things be able to expand their communications is going to be critical in the years to come. You know, one area that's really in its infancy right now, but will continue to grow, is the connected health. You see these videos of a surgeon sitting in one country with a patient on the table and a machine over them a country away. And it's the need for extremely low latency in those applications that are critical to this world. And then just all the others, and we've heard them all, from retail through the ability to just be able to have entertainment expansion. All these are going to continue to be driven by the use and benefit of 5G. I think one that hits home a little bit more, though, is the connected mobility. And as you look here, it's going to be across a full range. It's not just the car, but it's how a car may interact with a parking garage to understand if there's available spaces. It's how we use vehicle to infrastructure to understand planning for truck routes. It's the ability to have the vehicle to vehicle for warning systems. All of these will continue to be able to enhance our world and bring us into the next generation of technology. Now, if we think about the autonomous vehicle, because in my mind, that's the first thing you go to, I take a step back. And if you think about every time you get in your car and what senses you use to drive that vehicle, to me, it's your eyes and your ears to some extent as well, but it's two eyes that are scanning as you continue to drive, using mirrors to look backwards, using forward and side vision. So it's, what is the autonomous vehicle going to do to be able to move into this world? Well, as you look at the advancements in this, it's really going to be more sets of eyes. It's cameras forward looking, it's cameras to the side, it's cameras to the rear, it's cameras above. So we really see in this 5G world the ability to use this type of methodology to improve the autonomous vehicle. What it's not going to be, we think, anymore is really a radar-based module. In the latest version 9 software update from Tesla, they actually have been pulling out some of the radar functionality and replacing it with camera-based functionality. Because as they've learned, radar can have some limitations to it. But the more, for lack of a better word, eyes you put on the road, the better we're able to make this autonomous vehicle work. What comes with that, though, is the need for more antennas. It's a connected system. So you'll continue to see actually an expansion of GPS, Wi-Fi antennas, along with your AM, FM, and LTE antennas. It'll continue to be a connected vehicle, not just an autonomous vehicle. So that comes with the next set of challenges, and that's managing all of this data that's now going to exponentially grow. So the vehicle manufacturers will need broad data center capabilities, which quite frankly, we need to be carried over 5G. It's going to be a little difficult to have, wired cars driving around. So 5G is going to become a critical aspect here to enable the autonomous vehicles and remote management systems. We're going to have data centers at the edge. So how do we get creative in being able to have areas to have this upload of massive amounts of data? You'll have car to car, you'll have car to point of sight, but they're talking about using the charging stations not only to basically recharge the batteries, but more importantly, to be massive portals for data upload. We talk about data centers at the factory where they can then receive all this information and be able to real time feed it back out into the network. But what comes with that, though, is the government regulations you have to deal with as well. As we know in Europe, data privacy has become a huge piece of this world. So how do we protect this data that's floating through the ether on a regular basis? How do we ensure the privacy of the individuals? And then you're also going to have to really beef up cybersecurity, because we know the last thing you want is to have your car hacked while you're driving down the road. So these are all factors that really, as we make this next leap, are going to have to be factored in. It's really going to need expanded wireless access. So if you think about this, you have, let's say, a 20 to 30% increase in autonomous vehicles over the next 5 to 7 years. That means the amount of data flow, not only between the car itself, but between other cars, between line of sight, between anything going on, whether it be buildings, whether it be everything else, will need to be increased. The good news, 5G antennas are everywhere. We have the base stations that are in massive deployment right now. We're starting to see really the first and second generation of small cell antenna rollouts. We have the at-home devices that will continue to allow for broadband access out of the house as well, using a Wi-Fi router, using a set-top box as another point of data. So the good news is we have infrastructure out there already. Now, the one area, as we bring this back to a broadband show, is the fact that if you think about it, right now we have miles and miles, kilometers and kilometers of existing plant. We have copper and fiber plant out there that can be utilized. So this model really, stems more from the US as we look at this case study, because we have a lot of plant that's sitting in the air. So how do we leverage that? But in the rest of the world, in Europe, how do we leverage the underground plant that's sitting there, using the pedestals, using the boxes, using air strands to be able to have this signal magnification on a very high level of frequency as you move down a road, as you move through a city? We know that buildings are one of the biggest deterrents to signal, so we're going to need densification of the 5G nodes. We've continued to start looking at these things and understand what models can do, whether it be hanging from a strand, whether it be on a pole top, whether it be sitting on a building. But I believe over time, we as a cable industry will be able to leverage our knowledge and our plant to be able to help 5G evolve into this next generation. Thank you very much.
Thank you, Darrell. Perfect in time. And I would like to welcome now the awesome Ian Wheelock for the next presentation. Thank you very much from CommScope.
Thanks, Dominik. Hi, I'm Ian Wheelock. I work as a fellow within the CommScope CTO organization. with a focus on home networks, but have been dealing with broadband networks for since 1999 throughout Europe and the US. Today I'll just talk about Wi-Fi evolution in the home, how we go from the various standards that have been developed over the last 10 years to what it's going to look like in the next 2 to 4 years. So right now, over the last 10, 15 years, we've had quite an array of different changes to Wi-Fi. We've gone from Wi-Fi 5, 6. Most recently, we've engaged with Wi-Fi 6E, which is a brand new standard, which enables 6 gigahertz Wi-Fi. And now we have a burgeoning Wi-Fi 7 infrastructure that's about to be released. A big part of this evolution has been the different types of devices that have been used. So we've started with single AP devices, which most people are familiar with, and then evolved into mesh devices to give greater coverage in people's houses because of the limitations of Wi-Fi. And now with this new 6 gigahertz infrastructure, there's a lot of devices that are coming that are 6 gigahertz capable, but we're trying to utilize that for trunk backhaul links within the home. So we're able to give those mesh networks much greater coverage than we had before. The point about 6 gigahertz standard power is about the actual power levels allowed within the 6 gigahertz range compared to, within Europe compared to other regulatory areas around the world. And we'll touch on some of that later. So Wi-Fi networks have been used, ever since we got our first cable connection to the home. We've utilized Wi-Fi for delivering to devices. 2.4 is a very well-used standard, and right now with Wi-Fi 6, there are advances there which help with IoT devices, much more optimized IoT devices using that 2.4 gigahertz spectrum, allowing the entire house to be covered with a single radio. 5 gigahertz, which was introduced 10 years ago, has been used for the whole home distribution, mostly for video. And that's been a key component of all of the access points that operators have sold for the last 10 years. Now with this new 6 gigahertz edition, we've got different versions of 6 gigahertz, different things we can do with 6 gigahertz. The first one I show here is very low power, which is for indoor to devices that you can nearly touch. So in this example, we're looking at a head-mounted display talking to an access point. So we're getting very, very high speeds to these head-mount displays, but using very, very low power. We're talking about 25 milliwatts of power between these devices. And it's very much an in-room environment. The next step up with 6 gigahertz is the idea of low power indoor. And this is all about trying to address the regulatory concerns about incumbent users of 6 gigahertz, while also offering the maximum power we can get within a home. And with this new advance with 6 gigahertz, we've ended up in Europe with about 500 megahertz of extra spectrum that we never had before. That's a near doubling of Wi-Fi spectrum. In the US and some other regulatory areas, they have 1.2 gigahertz of additional spectrum that they're working with. And in those countries, there's a bit of a different philosophy as well around standard power. So as I said, we have 25 milliwatts for very low power. We have 200 milliwatts for low power indoor. And then in the US and other regions, we have 4 watts standard power, which is a huge increase and would allow for entire whole home distribution with just a single AP. Unfortunately, we don't have that within Europe at the moment. The other thing now is just about what's the capabilities of these APs that we currently deploy in the networks. So most deployments are using dual band concurrent, which is probably the mainstay deployment today. As you can see there, it's over 2 billion Wi-Fi clients shipped using Wi-Fi 6 connected to these APs. With 6E, as I said, we get low power indoor, and standard power options. And what's happened with 6E is because we have 3 different bands now, we now have to evolve into a tri-band connected device rather than a dual band connected device. But we do get 160 megahertz channels, which is a huge amount of bandwidth, really. And then with Wi-Fi 7, that standard has really boosted the amount of capacity we can get. So with Wi-Fi 6E in the US, you can get about 66 gigabits per second out of that available spectrum. In Europe, it's around 30 gigabits. But with this new Wi-Fi 7 standard, with the 320 megahertz channels and some other optimizations, we're able to get to nearly 150 40 gigabits per second in that US spectrum. Now, most devices are going to be much more constrained than that, but the capability is there within that spectrum. Now, in terms of the AP deployments, obviously, the operators have to see how we actually put this into people's homes. So Wi-Fi 6 is really where we are today. It's got the most number of shipments, and it makes up about 80% of the shipments that are occurring at the moment. And it's the most effective single AP solution. With 6E, we see as the time goes on, 22, 23, we're starting to see 6E being deployed, but it's not the mainstay. It's about 15%. And then Wi-Fi 7 will be released, will be certifiable by the end of 23. We see some pre-certified solutions coming before that, and then we see the mainstay start taking up in 24 and 25. So obviously we want really to embrace the 6E and 7 evolution, but there are some barriers to entry in this. One of the key things we need to embrace is the idea of a tri-band or a quad-band extender, or a quad-band access point. And this is really to be able to utilize those extra bands that we have and maximize the throughput. But obviously, there are some holdouts within Wi-Fi. So 802.11n, which is quite an old standard, it operates in 2.4 gigahertz primarily. That, continues to be a major seller of IoT devices and some smart cameras and things like that. So that's actually occupying a lot of the 2.4 spectrum. So we can't shift Wi-Fi 6 into that spectrum. That's the problem. Obviously, we're dealing with new dual band, tri-band, and quad-band access points, and that's really going to open up or enable that Wi-Fi 6E, 6 gigahertz spectrum. And the key thing with all of these new evolutions in the standard is they're really offering breakthrough performance. I've mentioned the gigabits per second, but latency is also much, much lower. There's some really fascinating technologies within Wi-Fi 6 that really enhance the behavior of clients connected to an AP, and that's really making a big difference to performance. One final point is about the SOC supply impact. Obviously, some of the 2.4 gigahertz only devices are based on larger geometries, right? And we all know there's supply chain issues, and it affects quite a lot of the older, larger geometry chipsets compared to the newer chipsets. So that may actually enable 6E or 7 to take hold quicker because that chipset will be more available. So some of the key drivers for Wi-Fi 6E and 7, right now the majority of traffic that we have in the home is video, right? So it's about 80% of traffic. The cloud gaming, it says there about 10%, that varies depending on what region you're in. But one of the key things about this new standard with 6 gigahertz is it's completely greenfield, unlike 2.4, which is very busy, unlike 5, which is starting to be busy. So with 6 gigahertz spectrum, we're now able to utilize it purely for 6 gigahertz, and we're able to use advances in the MAC to actually really improve the performance. So that's where our latency, jitter, and QoS become much more relevant. Some of the use cases for Wi-Fi 6 gigahertz really are the meshing options, video, distribution in the home, the 6 gigahertz 5G. So what we're talking about there is really about tethering, say, from a 5G device to a head-mounted display using 6 gigahertz Wi-Fi. So it's connecting over the LTE or 5G network to your mobile handset and then connecting that to your head-mounted display for VR, AR type applications. Obviously, with the bandwidth we're talking about, it's an obvious requirement for it's an obvious alternative to 10 gig cables within the home. So video really needs to adapt to 6 gigahertz. So right now, we really rely quite a bit on 5 gigahertz spectrum. It's getting very, very busy at the moment with all these other classes of devices present. So what we're really looking at is how 6 gigahertz, particularly in MDU environments, can really take advantage of the extra capacity, the extra bands that are channels that are available. So that makes a big difference to congestion in the home. And then the other use case are these immersive services, where we are talking about these head-mounted displays, the whole idea of virtual reality coming into the home. So we're taking advantage of high speeds to the home through DOCSIS 3.1, 4.0, or XPON, and then matching it to using the 6 gigahertz network to offer these new services. Now, as I said, 80% of devices today are Wi-Fi 6. They are not 6 gigahertz capable. So the question is, how can we actually accelerate that usage? So the idea that we're proposing is that we can offer overlay devices like these small APs that connect to an existing gateways to offer that 6 gigahertz infrastructure so as to enable that adoption much quicker. There's lots of new devices that are coming out as 6 gigahertz, but the AP in the home is the one barrier to entry. So by utilizing this retrofit feature, we're able to expand that into the 6 gigahertz space. And this isn't a new thing. We've already done it with 802.11n as well as 802.11ac in the past. So this is the kind of ultimate future home architecture, right? So we're talking about 10 gigabits is the new thing we're doing with DOCSIS 4.0 or XGS-PON. We're feeding a single gateway in the home, which then is offering the 6 gigahertz capacity throughout the home. So the green areas there showing the 320 megahertz band offer like a 20 gigahertz or 20 gigabits per second backhaul to the other access points in the home. And then each access point offers, in this case, nearly 5 gigabits a second to local devices. So we're talking about huge amounts of bandwidth. We're overcoming the problem of getting the 10 gigs into the home and dealing with how to get that around the house to all of the devices. And Wi-Fi 6E, Wi-Fi 7 enable all of that to happen. Okay, and this is just a repeat of that, but one of the things, and it's great that Dominik is here because from a regulatory point of view, within Europe and CPT countries, we've literally 500 megahertz of new spectrum that has been added, which is fantastic, but we also see other regions that have 1.2 gigahertz of spectrum, right? So it would be lovely to see how we can expand into that 1.2 space that's there. Another key feature is the standard power. So right now, the figures that you see there for the backhaul operate at 36 dB. So that's quite a high power. That is the 4-watt standard power we're talking about. And in the US, they've developed a system to allow that to be orchestrated or enabled on a per AP basis. We don't have anything like that in Europe right now. And if we had, potentially we could move to this much higher power. So that's a big consideration that our regulation people need to consider in the next couple of years. There's a WRC 23 conference next year, the World Radio Communications Conference, and hopefully there will be some moves, at least tabling some options about increased spectrum or more power. So just in summary, for future Wi-Fi enablement, we have the 6E spectrum, or the 6 gigahertz, so that's 500 megahertz today, with a variety of different power levels available, as well as retrofit options. Wi-Fi 7 itself is coming in 24, so that's really going to be where service providers start to get stuck in to offer this as an alternative Wi-Fi technology. And 10 gig, obviously, with DOCSIS 4 ESD and XPON gateways is coming. It's real. In some cases, it's here already. One of the key things about deploying single gateways is to try and make sure we can get the best cost for devices. So we did talk about retrofit, but we really want to talk about a single gateway which incorporates the high-speed WAN access as well as the 10 gigabit Wi-Fi together. And one of the reasons for doing that as well is to try avoid fragmentation of subscribers who end up buying off-the-shelf components from electronic stores that now take away from your option of managing their Wi-Fi. And the last thing is the whole marriage of DOCSIS 4.0 low latency DOCSIS and Wi-Fi 7 scheduling is really going to bring the QoE performance that people are expecting from this new 10 gigabit service. I think that's it. Yes.
Thank you very much, Ian. And I listened very careful when you spoke about spectrum regulation in European countries, because we know, of course, that Canada and US are in advance compared to us here. Yes, I know. But we will improve this. But together with I work for the Federal Ministry for Economic Affairs and Climate Action, and this is divided because together with the colleagues in the Federal Ministry for Digital and Transport. So we have it split up responsibilities. But now I would like to welcome very warmly Fabio Griffo from TP-Link, and he will talk about developments and evolutions in Wi-Fi mesh networks and customer premises equipments. The floor is yours.
So, thank you very much. I think my name is clear. I'm Fabio Griffo. I'm in the industry since more than 20 years, working for several companies within the wireless and, let's say, the networks business. And today I'm at TP-Link, and as we mentioned, we talk about today about evolution of Wi-Fi and Wi-Fi mesh networks. But I would like to bring to the attention of the audience the fact that I would like to talk a little bit how we deliver these solutions, this technology to the industry. Our focus definitely, and probably you know TP-Link already from user perspectives, the company is today not only focused in the deploying product and solution into, let's say, retail and consumer business, but today we are very much focusing in deliver services through the operators, the service provider globally. I'm personally responsible for the industry and the business unit in Europe, and we have a variety of solution technology and products which are deploying and delivering to the market thanks to our strong manufacturing chains and capability in engineering, development, and expertise in these technologies for, let's say, a number of, let's say, countries and territories where we today can reach up to 1.7 billion users. And it means that basically we touch with our hands the problems of the service provider who are today delivering these services, and where basically specifically the Wi-Fi mesh networks are really demanding, especially for the home connectivity. We, as I said, are able today to see the evolution of the market from the service provider perspectives, and we are already delivering to a number of customers. I would like to focus in Europe, the solution related specifically to the Wi-Fi mesh. It means that basically we have seen, especially in the last years, huge demand and a huge need from the service provider, but looking at what is happening in the home of the users, a number of, let's say, increased and boost of the acceleration of the requirement of having in-home, let's say, a stable, reliable, and trustful connectivity. And we have a number of examples that I will mention anyway, but with our solution, with our technology, today we were able, for example, talking about one specific case with Ziggo, to improve their NPS, the network performance score, meaning that we are very much looking at building technology for sure in full compliance to the standardization and the regulation, but definitely able to secure the performance in the home for the user, because from the service provider, these are elements which enable a better service to the user. With the Wi-Fi mesh, TP-Link is committed to the provision of a number of cutting-edge technology. So into this, we have a variety of product category for different access. Our colleagues before mentioned XGS-PON, definitely this cell is still there, but today also 5G with MBB device also for indoor gateway, indoor router connectivity are in the needs to bring Wi-Fi to boost the connectivity and to expand the connectivity within the different rooms of the home. And we have a variety of technology which are definitely bringing this to the market. Specifically, looking at the different Wi-Fi technology. We mentioned 6 and 6E, but of course we are also looking already into the deployment for the next years at the frequency band and the MPS regarding the Wi-Fi 7. And of course, all this technology, this cutting-edge technology, are fully compliant and support all of the certification and follow the standardization and the regulations globally. So let's go a little bit on what's going on in the home. And as everyone, as even my colleagues before have spoken, basically in the home, the Wi-Fi has become, especially in the last year with the advent of the pandemic, has become crucial. And of course, as I mentioned in the early beginning, so the connectivity doesn't only mean to be connected to an access to your own router, but the in-home mobility, but also the number of connected devices, also in the projection of having also today at home IoT appliances, meaning that the number of connectivity has been improved in a very, let's say, impressive way in the last few years, has become really that more than 15 billion Wi-Fi connected product has been used by the people on a daily life, and consumer basically are spending hours and hours every day to stay connected at home, not only for their own, let's say, personal needs, but also for nowadays, also for business. Has been definitely proved clearly that everybody of us today can have a home office, and of course, not only data streaming, but as we mentioned before, video delivery is also, and video streaming has also increased. It means that basically savvy network users are really tech savvy, have to be there, and the speed and the seamless execution are primary factors. These are definitely bring to the home via different technology. In the past was most the VDSL, which then was follow up, and this is the bigger investment of the nowadays with the PON, with the fiber to the home, and definitely this means that the bandwidth, the higher speed has been increased, but also this means that every home is connected, every door-to-door houses are connected. The increase of the interference may be an issue, not only for the users, but also for the service provider who delivers the service for the home. And anyway, as I mentioned before, this is also due to the fact that the number of mesh services, networks, and related services from the service provider has been increased and are increasing. So, and this we have seen also with our analysis of the market trends, that the different Wi-Fi, also during the years, Wi-Fi technology has been moved from the 11N to the BG to the AX in the years, and we are seeing that with the advent of Wi-Fi 7 in the next few years, the BE will be there. So the number of coverage with Wi-Fi devices has been improved, has been increased dramatically, and also on our own experience, today we are delivering at least with the last number of 2021 around about 9 million mesh supported device worldwide. But why TP-Link? So, and how we provision this? So we definitely are, as I said, committed to release and deploy and ship cutting-edge technologies which are covered by a number of product variety, from the pure networking to the extender, access point, PoE, and so on, power line, and so on, all supporting a standard easy mesh. And we definitely follow the trends of the technology and the standardization evolution. Today we are supporting in our easy mesh device the R2 version. Within next quarter we will be releasing easy mesh R3 and R4, and basically this means that we are compliant to standard, interoperable to any routers, interoperable to any, let's say, requirement and networks of even competitor devices. So wherever we are interoperating in the network, let's say, home network preparation. And then, of course, we have the advantage to have know-how and knowledge engineering-wise on built-in artificial intelligence element at, let's say, algorithm or software level. On top of it, building basically intelligence and bringing also intelligence to the home and creating an intelligence home network utilizing our own products, which are able, for a number of reasons, to interact better each other with the use of definitely 6 gigahertz for improving, for example, backhauling, interconnectivity between the nodes, but also utilizing, let's say, intelligent antennas with smart antennas for better connections. This creates definitely the difference. We have been definitely recognized by service provider with the increase of their own NPS, bringing their basically customer success rate in their own calculations at a very advantageous parameters with less, let's say, service call from the user to the operator for support, and minimizing the misefficiencies into the home network. This also brings the reason why we bring today 6 gigahertz solutions and 6 gigahertz spectrum solution, improving the performance in terms of congestion-free, additional throughput, lower latency, that we are, for example, able to decrease below the 50 millisecond at the 60 gigahertz band. In addition, of course, we do not have to forget that when you want to build a home network, home mesh network, definitely you need to give the power or even the advantage to the users to have an intelligent way to configure the network. So we have a solution which are definitely built in our product that facilitate also the access, but the plug-and-play configuration of the network itself. And then I would like to give a little bit of an advantage of looking yourself at with a nice video, the type of user experience we create. And I would like to highlight that this can be brought indoor, but also with our product, with our solutions, also bringing this to the outdoor cases, bringing into different form factor in the PoE, let's say, selling the ceiling mount, or even in extending the signal in different rooms at different levels, independently of the let's say, the configuration of your house. As I mentioned, the outdoor solution, and of course bringing into the home Wi-Fi mesh toward different technology and different access technologies, for example, including the 5G DECO solutions. In addition, definitely the intelligence to manage via cloud the network in the home. Every operator, every service provider not only look at the home network, but also look the way how they manage. There are third-party solutions. We have also our own TAUC proposition, which I would like to give you also through a short video itself. We bring TR369 management. I don't know if it starts. Yes. And and what is TAUC? Is a simple leading standardized management, cloud management platform, which bring to the operator the capability to remotely manage and understand what's going on in the home of the user, how to immediately react real time to eventual deficiencies or issues at any technology level, and help the user on real time. Similarly, we can do this on the user interface with apps on their own smartphones, so that even the user is able to understand a little bit better what does Wi-Fi really means at home. And you can see the different user interface with dedicated applications which are giving the different configuration or customized interface so that any operator or any user can identify what level of parameter they are more relevant for them. And of course, in terms of Wi-Fi, we mentioned before the advantages of Wi-Fi 6E with the 6 GHz band, but we know that also Wi-Fi 7 is arriving for a number of additional advantages, more reliable performance in crowded network specifically, but also increased transmission efficiency. And of course, this is something where I would like you to suggest to talk with us directly in our booth. So, thank you.
Thank you very much, Fabio, for this very good, interesting presentation. And now I would like, last but not least, I would like to introduce Jens Bundgaard from Isotera AS for the last presentation for this morning in this panel. Wi-Fi at the next level, 8x8 high-end Wi-Fi 6.
Good morning, everyone. My name is Jens Bundgaard. I'm from Isotera. Isotera is a relatively small company. We are not the TP-Link, we are not the Sachem-Com, but we are a company doing CPEs and residential gateways. Sorry, thank you. That's a good height. I've been in the business for 20 years within the fiber optic industry. I've been doing network monitoring, and now I've joined Isotera a couple of years ago to support Isotera in the Wi-Fi support, the Wi-Fi strategy, and how to develop the market within high-end Wi-Fi solutions. A short company introduction first. As I said, we have 4 pillars. We're doing fiber termination products, which means GPON, XGS-PON, 1 gig, 10 gig. We do managed Ethernet routers, mainly focusing right now on the Wi-Fi 6. I'll get back to the discussion around Wi-Fi 6 and 6E that we've been covered a little bit earlier in earlier presentations as well. We are 115 committed people, so as I said, we are not a big company, but we have 90 people sitting in Poland doing development, design, hardware, and coding. Main office in Denmark, and sales offices around Europe in Sweden, UK, Germany, which is our main markets. We've all been talking about, we have a lot of talk about mesh. We just had the last presentation here. We're actually going a little bit different way. I'll look into this in a few minutes. But we do obviously have managed access points as well. We do mesh in Isotera. It's not like we don't believe in mesh. But a quick question for the audience. How many of you actually have a mesh system deployed in your home? Okay, so approximately half or something. Okay, good. I'll get back to that one. The last pillar we have is again in-home monitoring. Very often operators, ISPs, are totally blindfolded when they deploy a router at the customer's house. The customer calls in, I have problems with my internet, normally they say, right? But the actual issue is more likely to be the Wi-Fi. And that's why we do this in-home monitoring solution where we can actually have insights and we can do actions based on these insights on the customer premises, or we would actually know before the customer calls that he has a problem and might call us in a few minutes. Along with this, we also have our end-user app, which is used for Wi-Fi optimization. But I would say, regarding the optimization of networks, in-home networks, a lot of the intelligence is actually inside the CPE itself. So we don't need any advanced cloud-based solutions to do intelligent configuration changes in the network. We can actually ask the router to do it itself. One example is use of high power channels on the Wi-Fi 6 in the 5 gigahertz band. If you look at that scan in a normal premise network, and you look at a scan of 20 channels, many of those channels will actually use the lower part of the 5 gigahertz. We still have a relatively big window in what we call the DFS channels, but we just have to use them intelligently. The DFS channels gives us much more power, and that's something we are using a lot in Icotera. So, looking at a little bit into the market trends. If you look, this is mainly focused on Germany. It might look different in other countries, of course, but we have a transition, first of all, going from DSL, some coax into fiber. We have at least maybe 300 megabit as becoming the standard offer. In the Nordics, we even see 1 gigabit is a standard offer. And we have increasing expectations to have a very good Wi-Fi performance. And these are what we call the market drivers. The other things we can do is actually the differentiators, how to differentiate ourselves as an ISP towards the customers. First of all, the superior Wi-Fi performance. One thing is coverage. We can get coverage by deploying 15 mesh devices around the house, but we don't necessarily get the performance. And that's exactly the issue in the Telenor case I will cover in a few minutes. And then obviously the in-home monitoring and support, having the possibility to have insight into the home and offer a proactive support to customers in case of problems. So, again, back to the distance and performance discussion. If we look at Wi-Fi 6, I know I'm maybe going a little bit back. Everyone is talking about 6E and 7, and it's all coming, and it's nice and good. Wi-Fi 6 gives us more bandwidth, but actually not that much more. It's around maybe 20-25%, but it's also giving us a lot of stability. It's giving us less latency, and I know 6E is going to be even better, but that's a different story. But Wi-Fi 6 also gives us the possibility to have deploy more antennas inside the CPEs. I know it's actually technically possible to do it on Wi-Fi 5 as well, but on Wi-Fi 6 we can do on 5 gigahertz we can deploy 8 antennas on the 5 gigahertz band, what we call 8 by 8 because we have 8 for transmit and 8 for receive. And this amount of antennas inside the CPE is not seen everywhere. A lot of ISPs are talking about Wi-Fi 6 and still deploying a Wi-Fi 6 device with 3 or 4 antennas. What we say is, if you want to go the Wi-Fi 6 way, you should do it in the right way. So we have to do it right, and we have the possibilities to go quite far with Wi-Fi 6, which will give us a big advantage because then Dominik and his colleagues will have time to get the regulations in place regarding 6E, and we'll have all the regulations in place that we're still, I would say, missing on the 6E. So what does that mean, the extended range? The new thing is, if you deploy 8 by 8 antenna solution inside the CPE, you would have the possibility to not having the need to decide whether you want distance on the 2.4 or you want performance on the 5 gigahertz. That was the old days. Now we can actually get distance and performance using these 8 antennas. And these are thanks to the beamforming technology that we've known from the mobile world for ages. We do it in Wi-Fi as well. We've done it for a long time, but the more antennas, the better performance and the better distance we have. It doesn't mean that 2.4 is dead, of course, because 2.4 still needs to cover the legacy devices, like microwave ovens, and that's a bad example because they're running the same frequency, but it could be baby alarms or anything that's also important, but will be a different ballgame. And the reason that this is really nice is that if you use, and I'm not talking about tri-band solution, that's a completely different story. I'm not talking about cable access points, but if you look at the setup of a router, access point, and a device connected with a wireless, you can consider the access point in the middle, the repeater, as a half-duplex technology. That's how Wi-Fi works. So that means that you would actually lose 50% of your throughput when deploying this setup. And that's exactly one of the things we want to avoid by having a load of antennas in the CPE and trying to decrease the amount of extra repeaters and mesh devices needed. So a little bit different approach. What happened when Telenor went to Icotera was they said, we want to be the best. We want to have a market position in Sweden where we can deliver the best performance, but we also need the simplicity of having as few devices in the home as possible. It's easier for the customer. They don't need to use power plugs everywhere. It's easier for our support actually to help the customer in case of issues by looking only at one box instead of 5. So the whole setup would be much more simple for everyone. And they actually succeeded. After only a few months, they realized that they were ahead of competition in this. They got very, very good feedback if the customers are calling them, because that was the next issue. When Telenor Denmark started to roll out these devices from Icotera with 8x8, the product and partner manager at Telenor Denmark told me that the amount of support calls actually dropped by 60% on this router alone compared to all the legacy stuff they have. So that tells us that the strategy is right. We're going the right way with this kind of technology. And I know everybody else is talking about mesh, and we still do it because sometimes you simply have a home which needs another access point to cover everything. But this is what they did. So just to explain what's actually happening. In the old days, Telenor would equip a home with a typical 4x4 router, 4 antennas. Now we're only talking 5 gigahertz. Then maybe placing an extra repeater somewhere in the house. If it's too far away, of course, we need to pull a cable, which is maybe not technically it's the best way to do it, but in real life, it's very rarely going to happen. Alternatively, we can use this extra access point nearby, near the router. They can communicate on the wireless backhaul, but the challenge is exactly that inside this area of where the access point and the router is actually communicating, we will lose 50% of the throughput. And that was one of the biggest problems. So what Telenor decided with this solution was to deploy this 8x8 solution, getting rid of all the complicated stuff, and only have one device in the house covering the whole area. Actually, they realized that only 8% of the customers today needs an extra repeater to cover the whole premises. This was confirmed by Calix as late as yesterday. They told us, or they had this press release saying that mesh is actually only needed in, they said 7% of all cases. If you use the right router setup, you can avoid the mesh. So that was confirmed by Calix as well. Obviously, less repeaters, less hardware, much more simple. We have less complexity, which will reduce the calls. First of all, calls coming from customers, but when they finally call, we need to treat them proactively. It's a simple setup with one device instead of 5. It makes supporters' life and customer life much simpler. So at the end of the day, also a better customer experience. And on a final note, we've had a little bit of discussion on 6E. Our belief in Icotera is that 6E, first of all, 6 gigahertz is really nice. We really need this extra bandwidth. But again, like in the 5 gigahertz, actually, we see the US, we see Canada, we see a lot of countries having the full spectrum of 1200, and we will only get 500 in EU, and that's a problem. We have a big limitations in that aspect. The other one is that we don't have any high power channels like we do on 5 gigahertz. And the third one is propagation of 6 gigahertz compared to 5 gigahertz is a lot worse. It's really bad, actually. If you go to make a simple transmission through a brick wall, you would lose close to 10 dB if you compare a 5 gigahertz and a 6 gigahertz. So even if you have the 160 megahertz bandwidth compared to the 80, which would basically give you double, you are still only getting a little bit ahead with the 6E through a brick wall. So we think that the best way to handle this situation for the future is stay with Wi-Fi 6, get a powerful router that would actually last more than a couple of years, and wait for 7. Wait for Wi-Fi 7, because at that time, Dominik and his colleagues would hopefully be able to solve all the issues, all the regulatory stuff, and make it happen. So that was my final words. Thank you very much.
Thank you very much, Jens. Now we have heard 4 very, very good, excellent, interesting presentations, and now it's up to you to raise questions to the audience. We have 2 mics on the left and on the right hand side. Please use them and say your name and the organization or the company you represent, and to whom you would like to address your question.
Jacques Abramovich, TMT Consulting. I have 3 questions, one general, one to David, one to Ian. The general question first, what I missed in this presentation is security. A lot of IoT devices still use WPS. A lot of servers for updates are still not signed, so basically IoT devices are still the weak spot for entering a home network. So that would be one thing I'd like to address, also if the EU is planning anything on that. My question to David, you spoke about the high power, the new high power. Have there been any health studies if there's any impacts on that? My question to Ian, you spoke about upgrading existing using Ethernet. Most routers tend to have a 1 gigabyte port, maybe a 2.5 gigabyte port. So what's the point of adding a 20 gigabit wireless throughput if you are going to use a break of the 1 gigabyte port? Thank you.
Thank you very much. Perhaps for the first questions, any one of you who would like to answer to the security issue? Yeah, Ian.
So yeah, there's a lot of work going on with Wi-Fi Alliance to improve the security of devices. Obviously, within Wi-Fi 6, we're now talking about WPA3 requirements, which have really moved the bar for security. For IoT, you're obviously right about WPS as a basic way of onboarding devices, but yet again, Wi-Fi Alliance have come out with Easy Connect, our device provisioning protocol, which will allow far more secure onboarding of IoT devices into the network, which is certificate-based, which makes a lot of sense. Just in terms of the service updates, certainly from an operator perspective, the general approach that they all use is to have fully signed updates of their access devices, whether they are extenders or whether they are gateways. Beyond the operator network, obviously, you need to have regulations to ensure that those updates are also signed. So I think within the industry, we're certainly addressing the IoT concerns and the security update concerns as well. That question, okay. Yeah, so at the moment, you're obviously right that a lot of cable devices are equipped with 1 gigabit per second Ethernet ports, and we are pushing Wi-Fi 7, and we're talking about 10 gigabits per second and whatever. A lot of those are marketing figures for a start, okay? A lot of them are also, because of the way Wi-Fi works, I think Jen's made a point, it's half duplex. So when you look at 5 gigabits a second Wi-Fi, in theory, it's half duplex, so it's half those speeds. And then we come back to the SLA, right? So you're selling a service to a customer. Somebody mentioned 300 megabits was the standard kind of rate in some countries, whereas in the Nordics it's a gigabit per second. I mean, at the end of the day, the point of the operator providing Wi-Fi is to make sure they can get that bandwidth to all the devices in the home. So their primary concern is to match the SLA through the rest of the house. So obviously, over time, those bandwidth increases will occur, and that's why we are provisioning, we are upgrading to 2.5 gigs interfaces to support that upstep from 300 to 1 gigabit to beyond. So you're right that the PHY layers are capable of much higher speeds than the SLAs are, but we're provisioning it to enable future upgrades. Thank you.
And the second one was to Darrell.
Yeah, just turn it on. So, to be honest, they are. So, their studies are ongoing, and it's very early at this point. So, there has not been any significant data that I've seen put out yet, but I know it's ongoing because they feel the more this proliferates, the more it is going to be an issue. So, I don't have a good answer for you right now, other than I know they are working through that.
Thank you very much, Darrell. Are there any more questions in the room? Yes, please.
Yeah, thank you. So is it Mark? Yeah, it's on. Detlef Führer, Hewlett Packard Enterprise. Actually, I have more of a comment than a question, I must say. First of all, I must say I'm very happy that this panel addresses a topic which should be very high on the priority list of network and fixed network operators, which is how to ensure that that users can actually use the gigabit speeds that are delivered to the home through Wi-Fi. And thanks Ian also and Jens for covering or addressing the spectrum issue. We heard that Wi-Fi 6E in Europe at the moment has only 480 megahertz of spectrum, except the UK, we have 500, whereas in other parts of the world, US, Canada, South Korea, Saudi Arabia, Brazil, lots of parts of Latin America, we already have 1200 megahertz. And for the future, this is going to be essential if the gigabit speeds should be extended to the user. So Ian mentioned the World Radio Conference next year. Well, the WRC is not going to talk about Wi-Fi spectrum, I'm afraid, but there's a clear risk that in Europe the 6 gigahertz band could be split, which, to be very clear, would be a disaster for Europe and for fixed broadband network operators because the limitation of spectrum would limit the attractiveness of the offer. So what I would say is, in my view, equipment manufacturers, network operators should get involved. Talk to your regulators, get involved in European level, national level, and make clear that more spectrum for Wi-Fi is needed. Thank you.
Any more questions? Okay, so we've finished just in time. I would like to thank again all the four presenters here, and I would like to thank you for your interest and wish you a great remaining day here in Cologne at AngerComm or in the city. Thank you very much for joining us, and goodbye.